What happens if our mysterious black holes are destroyed? We all know that it's not that easy to destroy a black hole that easily. As black holes can absorb everything due to their insane gravitational pull, there exists fear in everyone. But if we consider the impacts that will be received from the existing black holes, do you think destroying a black will save our universe? In this video, let's discuss the impacts of destroying a black hole. Let's begin. Black holes are formed of materials packed so tightly that gravity dominates all other factors. Because the material is tightly packed, a bowling ball feels weighty in your hands. You could eventually create gravity that would have a significant pull on traveling light if you continued to cram more mass into the same little space. Black holes are fascinating to physicists because they represent the point at which gravity, the theory of the very large, and quantum mechanics, the theory of the extremely small, collide. In a black hole, we have a hypothetically very small object, possibly a quantum object with a tremendous quantity of gravitation. A quantum theory of gravity, currently regarded as the pinnacle of physics, might be developed as a result of understanding these black holes. Stellar black holes, supermassive black holes, and intermediate black holes are the three categories of black holes that astronomers have identified. The accretion disk, the event horizon, and the singularity are the three layers found in the majority of black holes. The area surrounding a black hole's mouth where light cannot escape is known as the event horizon. A particle cannot return after it has entered the event horizon. Across the event horizon, gravity remains constant. There could be more than 100 million black holes in the Milky Way. Sagittarius A is the name of the supermassive black hole that has been discovered at the Milky Way's center. The supermassive black hole at the center of our galaxy has finally been captured on camera. There are several numbers of ideas put forward by scientists in order to destroy black holes. Not many have failed. One of them was based on the concept of anti-black holes. The idea was to throw an anti-black hole to destroy the existing black hole. Do you think that is even possible? Also, does that have any impact on our Earth and universe? Nope. That merely worsens the situation. The two particles are frequently annihilated when a positron interacts with an electron, leaving just a pair of photons behind. Since the photons are trapped inside the black hole still has the mass that corresponds to its energy. Thus, rather than being reduced by the mass of the electron, the black hole's mass is enhanced by the mass of the positron plus the corresponding mass of its kinetic energy. Antimatter and matter don't just cancel out when they come into contact. Instead, the sum of their masses becomes energy. So, adding antimatter would just make a black hole heavier and more hazardous. From our vantage point, whatever is hurled into a black hole stays outside the black hole. Therefore, after a black hole has fallen within its event horizon, there is no way to change the observed mass of a black hole other than perhaps by Hawking radiation. But besides all these inventions in destroying a black hole, do you think what might happen if the black hole vanishes all of a sudden? Will that affect our universe? Or if that brings any changes to the galaxy? There is something called Hawking radiation put forward by the scientist Stephen Hawking. So let's see what this radiation can do in the destruction of the black holes. It appears that some black holes have non-stellar origins. Large amounts of interstellar gas are thought to gather and eventually collapse into supermassive black holes in the cores of quasars and galaxies, according to a number of astronomers. It is expected that a mass of gas entering a black hole quickly will release more than 100 times as much energy as the same mass undergoing nuclear fusion. Therefore, the massive energy production of quasars and some galaxy systems would be explained by the gravitationally driven collapse of millions or billions of solar masses of interstellar gas into a giant black hole. However, Hawking maintained that it is impossible to trace black holes back to their origins, given our current understanding of them. You cannot determine the kind of stars that have entered a black hole by observing its radiation. This is so because thermal radiation, which cannot carry information, escapes from black holes. Hawking also found that the information couldn't remain in the black hole indefinitely, and if it is unable to endure the radiation inside as well as outside, it will be destroyed. The answer, according to a team of scientists who just released a fresh study, is no. An area known as the event horizon entirely encloses the singularity in a black hole. This barrier is not constructed of anything. It is merely an imaginary sphere where the space-time bend is so great that light cannot escape. This sphere's radius is known as the Schwarzschild radius because, as you might expect, it was determined by our volunteer lieutenant from World War I, Karl Schwarzschild, using the answers to Einstein's equations. Any objects inside this event horizon, including the singularity itself, cannot be seen directly because no light can escape from there. Anything that goes over this horizon is irrevocably sucked in. Black holes are viewed as a particular type of edge of space because of this. Black holes are regarded as a specific type of space's edge because of this, one route only out of our universe. We are aware of no communication between anything inside a black hole and our cosmos, even in theory. Hawking radiation, according to Stephen Hawking, is a type of radiation that black holes can produce. The radiation that results from quantum phenomena close to a black hole's event horizon leads the black hole to gradually lose mass over time. Primordial black holes are extremely tiny black holes that can totally dissipate over a very long time. In the final seconds before it vanished through Hawking radiation, a black hole would unleash a burst of energy that would have some influence on its surroundings, although the total effect on a galaxy would probably be negligible. So practically, if we try destroying with the idea of Hawking radiation, that doesn't make that much of a bad impact on the surroundings. So, do you think this is safe? When two or more black holes come close together, they may merge. There may be a considerable discharge of gravitational waves and energy during this merger process. Depending on the precise circumstances, a black hole merger can produce either a more powerful black hole or the creation of a brand new black hole. So does it mean that nothing will happen if a black vanishes? Wait, on neighboring stars and other objects, black holes have a powerful gravitational pull. The gravitational dynamics in the black hole's immediate surroundings might change if a black hole vanishes quickly. This may result in modifications to the orbits of neighboring stars, which may result in the expulsion of some stars from the galaxy or long-term changes to the galaxy's structure. So, should we fear a structural change in the galaxy? Destroying the black holes is a lifesaver in real, but practically, it is time-consuming even if the scientific ideas are applied. The only thing that we can do is wait. So what do you think about the impacts of destroying a black hole? Even if the structure changes, does that affect our Earth and the surroundings? Share your thoughts in the comments section. If you find this video helpful and informative, give a thumbs up. And if you would like to know more about the updated space-related information, subscribe to our channel and click on the bell icon to stay updated. See you in the next video.